At the beginning, I'd like to remind you to switch off the phone or turn on to the silent mode to not interrupt the presentations. Today's talk is about character and animation tools we use in the Sniper Ghost Warrior 3. Who I am? I'm Paweł Dziągwa. I'm senior technical artist at CI Game. I work in the Rzeszów studio. I work on the Sniper Ghost Warrior 2 DLC, Enemy Front, and currently on Sniper Ghost Warrior 3. If any of you are interested in our latest project, please visit website sniperghostwarrior3.com. Some of you may be familiar with the character in the screen. For current project, we use the 3ds Max biped. We add some enhancements, some additional tools to the biped, which make our work faster and get better results. In the project, we use 4 different proportions for our characters: kids, female, male, and bigger male. We add extra bones on the hands to get better deformation, better articulation on the hand, especially in the FPM mode when the hands are visible on the screen. Also, you can see on the screen, we add quite several additional corrective joints that allow us to make better deformation on the characters. All these joints are driven in the 3ds Max Studio where is work in real time. Later on, all this animation on the joints are baked and used in the engine as animations. Why added corrective joints? Main reason is to get better deformation on the characters, fake the muscles, because in the real time is too complicated to have the real-time muscle. In the CryEngine, we use dual quaternion skinning method instead of linear skinning. So in the screens, you can see the differences between the dual quaternion and the linear skinning. Mainly in the elbows and knee, we have the bulge, but generally dual quaternion gets more rigid deformation, and you can see on this screen, it doesn't have the candy wrap effect. Wait a second. But the worst idea is here you have comparison on the right side is not corrected shoulder area. On the left side, we have corrected shoulder area. As you can see, left side looks a lot better deformation in the shoulder area. Also, we add additional bone in the clavicle area. We have a lot of vests and a lot of this kind of attachment for the characters. We don't want to, this vest will be glued to the shoulder area. So we add the additional bone, the skinning vertices don't move on the rotation, just rather than translations. Hold on a second. We have. Mam jeszcze raz tą prezentację, ona jest na pewno z tego miejsca odpalona? Dlaczego on nie widzi? sprawdzaliśmy i działało. Takie włączanie będzie uciążliwe.
Tak,
Okay. Ale wcześniej było po prostu, nie widział ścieżki. So now should be faster. Here you can see the result. The same right side is corrected. This side is not corrected. I don't know if the result is clearly visible. It's a subtle effect, but allowed us to get the little sliding effect on in this area. To get better deformation on the hands area, especially on the wrist area, I've wrote a pose reader for the hands. Basically, this allows us to drive the correction bones depending on the orientation of the hands. We have specified the vectors orientation, and if closer the hands is to this vector, this pose is applied to the correction bone. As you can see in the up example, the wrist get better deformation on the lower. Is visible the effect where is wrist here have the more rounded, more errors on the skinning. Also, we add the additional bone to the hands to get also better deformation between the fingers. Also, you can see this deformation, the bulge here, and no bulge in this example. We have the bones that drive the correcting blend shapes or the corrective morphs in the engine in the real time. Is not used very often, but it sits in the rig just in case. Some IK we use. Here's the rig modifier. This rig modifier allows me to control the visibility of the rig. So I can toggle the figure mode, toggle the box mode, so artists don't need to manually switch the visibility mode. Again, they can quickly switch the visibility mode, switch the his proxy, show, hide, correction bone, IK targets very quickly. Also, in this rig, I store all the joints, joint arrays. So later on, I can simply validate the skeletons if any additional object is not parented to our exporting skeleton, because in the biped, in our case, our control rig is also the exported hierarchy that is used in the engine. So you can see in on the action. So I can quickly turn on and off the figure mode and toggle the different display of the rig. Also, the rig have implemented function to renaming all the biped bones. So in case we have 2 or more characters in the scene, we can rename them very quickly, and later on get the information which bone is assigned to the different skeleton. As you can see, this is the example of validating the skeleton. I can link any type of object, and it prints me what object is currently connected to the skeleton and shouldn't be connected to the skeleton. Also have the function to remove and include or exclude, and simple zero outing some of the joints. And the renaming function. So I can, in one place, can specify the prefix for all the joints. This renaming function is also used in the other different tools. So the other scripts can communicate with this modifier and do something with the rig. Basic overview of our character pipeline. We have created the base mesh. This base mesh is delivered to the character artist, so the character artist can know exactly how the proportion, how is the proportion of the character, where the elbows, where the hands, and also they can reuse some of the parts of this body. For example, we don't need to create every hand again and again. We can simply use this rigged hand and speed up the full workflow. Also, I create some scripts that allow us to quickly get the character in the engine. So very simple, the skin transfer tool. So I can transfer the skinning information from the rigged base mesh and transfer to the character in the game. So sometimes we don't need to wait for the final mesh. We can take the high poly mesh, decimate it, and put it in the game. Check if the character looks okay, if art director is happy, if designers get the character they want. Or we can prototyping character more quickly. Later on, we can also, using the very simple tool, create the LODs. So also later on, we have the information how this character will be, how heavy this character will be for our game. We have a lot of characters, so we and the full-time process we can track how this will be affect our game. If any of you are interested in the character creation workflow, I recommend to check on GDC Vault, play the cutscene, the character of Rise. Another tool is, I can call it the hub for our characters. This is the character loader. Artists don't need to remember where the character is in the repository, how the character is named. Is the name that or different? Then can quickly search, filter the list, and load the character they need. We store the setup version of the characters and animation version character. This animation version of the file is optimized to get better performance during the animating. Another function of this loader is also we can load only the part of the mesh. For example, we can load only the attachment for the character, not the full file. So then we can reuse this attachment on load into another scene if we create the variations. Also allow us to load the weapons. So for the weapons as well, we don't need to look into the repository. Where's the weapon? How to apply it to the hand. We can quickly take the name of the weapon and assign to the hand we need. So it speeds up the workflow during the creation of the animations. Other functionality in the bottom where you have this tree, you can see what the rig is currently in the scene, what the weapon is applied to the character. Here you can see the list of all the attachments that I can load to a character. And filtering. Filtering supports the name and also the tags. So for example, when I create the character for the team, I can put all the names. So later on the animator could filter by, for example, enemy, NPC, all the other tags that character have. Also, this tool allows to change the LOD. As you know, mesh can be quite heavy sometimes, and it's lower the performance on the scene. So here you can change the LOD of the current mesh. So for example, if you animate and need to have in the full LOD the attachment, because you know you're creating the animation when a character grabs this part of the body, you can switch this part to the highest LOD and the rest put on the lowest LOD. You get the accurate representation and a good frame rate. BIP Explorer. We have also a similar tool for the animations. This tool allows us quick search, filter, and also save and load animations. Export the animation, support multiple characters, and is fully integrated with the perforce. So when you export the animation, all the animation file also are added to the change list, so you can put in the repo quicker. So here in the scene we have two main rigs. One I call player, one I call the enemy. So here you can have the enemy. This tool communicates with the rig modifier and use this functionality to renaming the characters. So we can rename and create the name. Later on for the export, we need to change the name back to the default name to the export to all the animation have the same name in the engine. All these functions are handled by this BIP Explorer. This tool is created by our senior animator. One feature that will be very useful, you can predefine your catalogs. So every animator can create their catalogs when he specify the animation, have the animation that he work, and later on he or she can quickly jump to this folder and load the animation. And as I said before, here you have the names of the loaded rigs. So here you can see the names of the character and predefine other catalogs that are not in the repo, they're on the local machine. One advantage of the biped is the loading animation and saving is very, very quick. That's allowed us to quickly iterate on the assets. We have similar tool for the FBX. For the retargeting, we use Motion Builder. Our animators know exactly how to work with the biped, know how to set up the scene in the Motion Builder to get good-looking animation on the biter later on. For some scene, when the biped directly loading animation on the biped not working correctly, we have created the binder script. This binder script allows us to sample the animation and transfer the animation on the BIP skeleton. This binder script handles, for example, the clavicle area where the biped have locked one axis. So in the Motion Builder, if you animate the clavicle in the x-axis, in our case, it won't be transferred to the biped. So binder handle that. Blend control is a simple script to allow us to quickly animate the blend of the eye case. Dynamic constraints, it's simply, I demonstrate. You can specify the parent and specify which object should be controlled. If you click the follow, if you make a key on the parent object, it's automatically create the key on the controlled object. And you can IK fingers. Biped has FK only animating on the fingers. This tool allows us to create the IK rig from the fingers and, for example, snap the IK on the word, or on the different object. So later on, I can copy the current pose to the biped. In the background, it's create another hierarchy, and later on, copy the transforms. So for example, if you have a weapon and you like to adjust the pose, when you move the hand in the biped by default, they also move the fingers. If this tool, you can pin the fingers to the weapon, for example. Also, our animator create the pose and hand explorers that allow to better handle the creating animation for the hands and transferring the pose. Here is the example from the hand explorer. What's the bigger advantage? As you see, you can blend between different poses. So you can have the dead base of the poses and quickly blend between the poses and create the final your poses for the rig. Pose Explorer have the similar functionality that BIP Explorer have, so you can store the dead bases, you can filter the list of the poses, you can turn on the preview for the pose, and you can apply the pose, for example, only for the hands, only for the arms, so allow us to quickly reuse some poses. For example, you have to have the some poses for some of the animations specified and common for the all part of the animations. We have a bunch of tools for allow the animators to work quicker. They are divided to the motion capture tools. Here you can example, for example, to calculating the speed of the animation is a very handy tool if you create the blend spaces of this kind of assets. Here you have an example. Biped don't have, for example, the reverse foot control. And this tool allows to pin the transformation, copy, and copy the transform. It's basically you can store the transform of the joints and copy them. Later on, you can specify the pivot point for the pose and simply paste the pose on the pivot object. You can change the pivot point of this selected joint. And here you can see the simulating, using this tool, the reverse foot control. You can change anytime your pivoting, so you can quickly place the pivot where you want, and using the slider, adjust the position of the bone. You can put on the side of the leg control if you have the banking. What's nice of this tool is that it is not constrained to the, for example, leg. You can use this tool on every object or every bone in the rig. So we can see it now. and in working with the biped layer system, because in work on the transforms directly. Now let's jump to the engine sides. What we have available in the engine in terms of creating the characters. In the CryEngine we have attachment system, and we have the joint attachment. It's basically attach the rigid geometry to the bone, and this attachment will follow the joint animation. You can set this as a face attachment. So basically, if you add the rigid weapon or any other attachment, and take the closest triangle and follows the closest triangle position, and the skin attachment. So this is a skinned geometry. Also, we create the special type of the object that allow us to more customized, because when you add the attachment, they are saved as a one character. So later on, if you like to create the variation, you need to store another file with the character. Our programmer create the object, then we can store, for example, few attachment, then the designer can switch between them. So for example, in this case, this character have set up some different hairstyles. So designer can quickly change the hairstyle of the character. Also, we have atlas texture for the characters, and this atlas texture is masked by vertex color. So as you can see, we can randomize how the character looks. So in this simple tool, you can create a bunch of crowds characters in the background. This is mostly used for the background characters. As you can see in the first empty model used as the skeleton, we export the simple triangle, and the skeleton is attached to this triangle. Every other mesh, body, head, and attachment are used as attachments. So we can use one shared skeleton and many of the characters. What's nice in the CryEngine is that you can add to the common skeleton something like the scale extension system. When you export the skinned geometry and add the additional joints, then will be the main skeleton will be extended of this additional joints. So later on, I can customize the characters, assign the simulation sockets for these joints, and make the setups more personalized. That you can add the joints to the main skeleton. You can simply extend the main skeleton very quickly. So I create the metadata system, then allow me to track which joints I added to the, which attachment. It's simply empty modifier, and added the attributes with the parameters block when I can store the different information about this attachment. So, for example, what's the location of the assets? What the type of this asset? What joint affects this skinned geometry? What the related other meta objects are used by this attachment. Later on, I can use this information on the other systems and allow, for example, to load the characters to the scene. When I load the character to the different scene, I don't have the additional joint in this scene. So I can load first the meta object, reads the additional joints, load the joints, and later on load the skinner geometry and applies the skinning. CryEngine allow us to use the different type of simulated sockets. That's the name of this system. Basically, this system is like you can make the stick on the fixed pivot, and you can constrain the motion by, for example, cone. So when you move the attachment, it will be swing or on the 2 axes, or you can constrain it to the 1 axis. You can use the constraint as half of the cone. Here you can see the example. You can use a cone, so the attachment swings not only 1 axis, but swing on the 2 axes. All these simulations are local to the character. So every time the character moves, the physics move the attachments. And of course, you can set the parameters like damping, stiffness, mass, and all this affect the simulations. Here is the spring ellipsoid attachment type. So if this type of attachment don't have fixed rod, so this function allows us to create the jiggle bones, the tissues, and this type of effects. So, and as you can see, it not only swings, but also have the movement up and down. Also, this pendulum row. So I can specify not only for one joint, but also for the entire row of joints. So in this step, I can set up the grid of joint and can simulate the cloths. And the CryEngine have a very nice collision object. So this simulation socket can not only be constrained by this cone of only the hinge, but also can collide with the special type of the collision objects. We have this collision object have 4 parameters, and using these 4 parameters, I can create the collision object. There is the sphere, the capsule, this rounded box. If I shrink the border width, I can create the box with the sharp edge or the plane. If you'd like to have more information about the simulation sockets, I recommend to check the technical artist bootcamp from the RISE. Have some information also about the simulation sockets and how they use the simulation sockets in the RISE. And here you can see example how we use this system in the game. So we can simulate the scarves, the cloths, and other additional object on the character. Every object have the. Here you can see this blue capsule will be colliding with these collision objects and try to rotate outside the collision objects. And we can also change the constraints for these collisions. Also, we can change the behavior, not to rotate outside the collision, but translate outside the collision box. This allows us to push the push the vertices outside the mesh. So we can avoid the clipping. Here you can see the example of the cloths using the systems. So you can see if I unhide the helper objects, the system not only use the one joint, but also the whole row of joints. And later on in the engine, he creates the grids. And you can see all these joints are pushed by the collision objects. What's nice with the system, this allow to stack these effects. So using the simple elements, we can create very complex effects. I see that the software don't likes me. Mm-hmm. But, okay. Mm. And here you can see example of the setup character. So you can see the cloth moving off the back of the character, and you can see the, I don't know if it's visible, here is the glasses and this is the tie. But again, okay, was not sure. Czemu to się nie pokazuje? No się coś tą prezentację, no właśnie. No to wychodzi. Bo się otwierało za dużo tego. Okay. Końcówka została. Here you can see the example. At the beginning of the project, I used the in a rig correction bone to correct this area. Minus of this approach is that this is baked. So for example, in the ragdoll, I don't have this effect. Later on, I try to move this, all the setup using the one collision and one translation. And you can see here, I get the effect where the hood is pushed by the head and avoid the clipping using the system. What's very nice of this approach is work also with the ragdoll. What next? CryEngine offers also some modifiers. So I can use the constraint point, IK, constraint line, constraint aim. Using them, I can move some of my setups, the real-time correction outside the max and push them to the engine. Later on, the next step, I can, for example, disable the effects with the LODs. So I get better deformation corrected and more optimal because it's disabled with the LODs. And it works with the in-game IK systems and the ragdolls. I'd like to thank you, the Grzegorz Rdzany, Damian Pajda for the animation script, all the CI Games team, and Crytek for making the awesome engine that we can use. And we are hiring, so visit the cigames.com if you'd like. And here you can, if you have some questions, I will be happy to answer them. And sorry for the technical problems during the presentations. Thank you. No, there's no Apex cloth. CryEngine, I don't know if you know, have own technology, so it's all built on the CryEngine technology. We don't use the middlewares. Yes.
This combination of random characters is the difference only on the texture?
Yes, on the diffuse texture. We create this texture sets. We create in that way, so we don't need to change the normal map and gloss specular, so we can optimize the textures in the engine and have different varieties. And for example, we don't have to use this. For example, if we'd like to make variation with the normal and specular, for example, we can create another character with different normals and specular if we need that.
How do you handle connecting the neck and the head properly with all the combinations you have? Don't you have any problems with character creations?
You speak about situation where the character artists make the higher and lower heads.
Yes, if you want to switch the heads or the body, do you have a very specific vertex line where everything has to be connected?
Yes, our heads ends up here. So later on we can cover the connection with the body and for example by the cloths. So the seam is not visible and is covered by the other attachments.
Okay, thank you.
Yes, and all the ponytails, long hair characters also are set up by the simulation sockets. I can put the joints on the hairs, skin the hairs to this joint, set the collision objects, and simulation do rest. Yes.
Do you use any extra tool for this lot generating part, like some Simplygon or I don't know, anything?
Mainly the lot creation is if I don't have the LODs from the artist. So I use the 3ds Max multi-res tool, and I found is good for me. It's worked best for me. In the script, I have also options to use, for example, the pro-optimalizer. But I mainly use the 3ds Max. And all these tools is only the some parts of the tools. In the given time, I don't have enough time to talk about all these tools. So, for example, we have also tools to exchange the skinning information between Max and Maya. Attachments are created for the given body, so the attachment fits to the body. So I don't need to handle the attachment. For example, attachment for the Bigelman is not used for or the regular skeleton. Or I can use the joint attachment or the face attachment. So these attachments are separate from they don't have fixed position. For the face attachment and the joint attachment, I specify the position where this attachment sits on the character.
Do you have any rig for emotions, facial rig? Do you have any system of showing different emotions or lip sync? Can you tell something about the facial rig, how many bones, stuff like that?
We're experimenting still with the setups, and as you know, the facial is subject for another talk. But yes, we work on also with the trilateral and test the rigs. So we test the 180 joints, and for example, for the background characters, we use less joints. Any other questions? If not, I thank you. If someone later on have another question, you can grab me somewhere here. So thank you again.